Hi, welcome to the Sigmetrix 3D Experience World presentation for 2022. I'm Kyle Heithaler, the Business Development Manager for Sigmetrix. Sigmetrix is a global mechanical variation management organization headquartered out of McKinney, Texas. My main responsibility is account management for the Central US and Central South America regions. I've been with the company since 2019, and I'm located out of the Metro Detroit, Michigan area. Sigmetrix has been a gold partner with Dassault Systems for many years now and have gold technology certification status for CE-TOL Six Sigma for 3D tolerance analysis with SolidWorks. Better products through mechanical variation management. This is the mission of Sigmetrix, and we strive to accomplish this with all of our customers that we work with. And we meet that goal in 5 different ways. Maximizing the return on your MBD and MBE investment, improving profitability by balancing quality and manufacturing costs, achieving faster time to market by reducing design and prototype cycles, delivering more innovative products through better understanding of mechanical variation, and capturing, transferring, and retaining critical product and process knowledge. You'll notice that all these initiatives are somewhat intertwined and feeding into one another. And some of the customers we work with may not need us to focus on all these. But normally when we help improve in one area, the others come along with it. So leading up to 3D Experience World, we spoke with some of our customers using SolidWorks and plan to attend. And from those conversations, it was identified that achieving faster time to market was the most important piece across the different industries. So today, I'll be taking you through how Sigmetrix can make this a reality for you. We all want to reduce development costs and time, right? We also strive to gain competitive edge by beating our competitors to market. Well, ignoring mechanical variation during the initial design activities usually causes multiple iterative design loops as problems are uncovered during validation, prototype, and pilot stages. Fixing the problems after they appear instead of preventing them initially via planned simulation activities leads to expensive engineering changes, added prototype costs, and delays in product release dates. Design engineering teams can reduce these costly changes and bring products to market more quickly by using Sigmetrix solutions to quickly build tolerance models to explore concepts, check product and process feasibility during concept and design, gain insights that prototypes don't typically provide, analyze product concepts that were previously too difficult to model, and then provide consistency of data and understanding throughout the process. For over 20 years, Sigmetrix has focused on ease of use, allowing more users to perform tolerance analysis quickly. This democratization of tools and information can be powerful, but it will provide no value to an organization if it can't be readily adopted and provide meaningful and accurate results that allow users and management to confidently make actionable decisions. So there are 2 common approaches found in companies for dealing with mechanical variation. A stack-up analysis is performed by an engineer or designer, most often in Excel, but sometimes by hand on paper. Some companies have templates or guidelines that engineers can plug nominal values from CAD models and tolerances from standards or legacy drawings onto. If the tolerance stack shows the limits of the specification will be violated, the engineer or designer will typically tighten tolerances on the parts that can be changed, or those costing the company the most money, and then move on. Companies that take time to do detailed analyses across their designs admit it just takes too much time, and in many cases lacks the accuracy of modeling real-world behavior necessary to avoid problems when production starts. On the other hand, the designer could make things look good in CAD, a design that's nominally perfect and looks great in design reviews, but ignores the analysis required to understand how real-world imperfect parts will behave. If they must dimension and tolerance prints, they might reference legacy drawings or similar products and copy the dimensioning scheme and tolerance values. This creates a false sense of security that no problems will occur once production starts. While this certainly doesn't seem like a successful approach, it's quite common. Over half of the companies we speak with admit they do some analysis, but most often on things deemed most critical, but they don't do enough. In either of these cases, design is thrown over the wall and manufacturing or inspection must guess on the intended function of the product or deal with the unanticipated variation while trying to bring it to production. The result? Over 70% of the companies engaging with Sigmetrix are seeking solutions to reduce manufacturing problems caused by tolerance issues. A third admit to wanting to reduce problems that arise after product ships to the customers. Both approaches are inefficient and lead to costly loopbacks in the design process. Sigmetrix provides simulation tools and education that enables design teams to build tolerance models that more accurately predict or simulate real-world behaviors in equal or less time than it takes to populate a stack-up sheet. This allows designers and engineers who are being asked to take on this new responsibility gain insight that help them design better products in a shorter amount of time. Although many companies recognize the usefulness of GD&T to better manage variation, it can still be difficult. The task of building tolerance stacks has traditionally been performed during the validation stage or later in production development process. Many companies continue to work this way today. This is partly driven by dependency that traditional stackups have on completed drawings. Those drawings feed into spreadsheets, and there is less opportunity to have tolerance analysis influence dimensioning schemes and, more importantly, design decisions. High-performing companies are taking a new approach and considering variations as early as concept and R&D stages. This new approach only needs very crude concept CAD models with surfaces and construct geometry that represents critical to function interfaces and critical to function features. This is like what some might call a skeleton model. Our simulation tools use simplified representations to create the variation models early in the development process, prior to final geometry being defined. Because of these models requiring little effort and being able to be built quickly, engineers or designers can build and compare many design concepts. Infeasible or costly concepts can quickly be eliminated, allowing the product team to focus on development concepts that are more likely to succeed. These models will remain associative to the CAD geometry and is updated throughout the development process. The models also provide the engineers and designers with valuable insights into the robustness of the design and the ability to answer questions they have about the design without being burdened by the often complex mathematics required to calculate the answer. These insights also help users make decisions about manufacturing, assembly, and inspection processes well before the CAD geometry has been finalized. Prototype, pilot, and test builds can provide valuable information during the development of a new product. However, physical prototypes can be costly and have significant limitations. These physical builds aren't able to provide a statistically significant sample size that represents the production volume of the final product. They don't typically represent realistic process capabilities of production manufacturing and assembly processes because better tools and more skilled operators are used. In other words, they typically represent the best assembly possible and not what's likely to be created during a final production. They also don't typically allow your team to look inside the product to determine the root cause of failure for critical to function requirements. Like other computer-aided engineering tools, Sigmetrix solutions are built on a robust mathematical model that can be used to simulate the impact of variation without the need of physically building a prototype. The video here shows insights gained from modeling the product in CETOL Six Sigma. This tool gives your organization the ability to simulate real-world conditions and make design and manufacturing decisions that are not typically possible with traditional prototypes. When going through design and prototype phase, wild and crazy concepts get through all of the time. It's not always possible to take these designs, though, all the way to the prototype and analysis phase due to the cost and time requirements. But what if it were a lot simpler to get the kind of feasible data you needed quickly? The images show machine gears moving to a non-metallic gear. Metallic gears have been manufactured for decades using hobbing machines where process capability for each feature is well known. Designer of a traditional gear system can reference charts and tables that give them the basic performance information based on centuries of empirical data. This legacy data is no longer relevant, though, when using new manufacturing processes or when the design is significantly changed. In many cases, the engineers are only making educational guesses and have no insight into the root causes that impact these specifications. Some of the performance specifications that have been addressed on gear systems with Sigmetrix solutions include backlash, chatter, tooth wear, and system efficiency. Without Sigmetrix solutions, a company would need to build prototypes and test rigs to collect this data, and even then, they may not have the full understanding of how variation is impacting the system. Product lifecycle efficiencies are not limited to the concept and prototype phases. Promoting a consistent understanding of vocabulary for sharing variation related to data and concepts can also help speed up the overall process. In an ideal organization, design, manufacturing, and quality departments all speak the same language and work together during the product development process. There's less room for miscommunication then that leads to misunderstanding and costly mistakes. The training solutions provided by Sigmetrix helps ensure that everyone in the organization can share a common understanding of what's needed and why during the product lifecycle. So throughout the discussion, I've mentioned our solutions a few times. Over the years, we've expanded these products and service solution offerings. We have our flagship product, CETOL 6 Sigma for 3D tolerance analysis. So CETOL works with all the major CAD platforms across multiple industry verticals. And if you started annotating your 3D models with GD&T, CETOL can import that MBD data, shortening that measurement setup. So EasyTOL is our 1D tolerance analysis software, taking people out of spreadsheets at an entry level. So EasyTOL was introduced about 4 years ago and works with most CAD platforms as well. And our standalone version specific to SolidWorks, CATIA, and NX added the capability early last year to pull in that model-based definition data as well. So our services include extensive mechanical variation management, consulting projects, and training. The training offered is both on our products as well as skills independent of the software, such as fundamentals for ASME and ISO standards, and advanced GD&T, tolerance analysis fundamentals, model-based definition, model-based enterprise, and many more topics. Additionally, we support a variety of delivery methods, a traditional on-site instructor-led training, virtual instructor-led training, and the big piece that's been hitting home for our user base is our new self-paced method offered through our computer-based curriculum. So as we wrap up, I want to review once more all of the ways Sigmetrix helps our customers make better products. Maximizing return on your MBD and MBE investment, improving profitability by balancing product quality with manufacturing costs, achieving faster time to market by reducing design and prototype cycles, delivering more innovative products through better understanding of mechanical variation, capturing, transferring, and retaining the critical product and process knowledge. Thank you for the time today. You can visit Sigmetrix virtual booth to explore more about any of our products, see demonstrations of EasyTOL and CETOL, or ask any lingering questions that you just may have for our virtual booth staff. Outside of the show, you can reach out to Sigmetrix team and myself at info@sigmetrix.com or by phone at the number you see here. Thank you, have a great show, and we look forward to seeing you all in person next time.